back to Welcome back to YouTube channel. Naren here. Today we will go through section 5.2. The first topic that we're going to cover is trigonometric functions of an acute angle. Here, since we're dealing with an acute angle, we assume that we have a right angle triangle. So this section is related with a right angle trigonometry. So we consider right angle. So one angle is 90 degrees and say we are given one acute angle theta. So in this case, whenever we have this acute angle theta, the side opposite to this angle, this is the angle, and the side opposite to this angle is this. This is called opposite side, or shorthand notation opposite, and this is called adjacent side. The side opposite to the remaining angle, not 90 degree, the third angle, and the side opposite to 90 degree is hypotenuse. So shorthand notation HYP and adjacent ADJ. Sometimes people also like to use more shorthand notation around the globe. They use opposite side as a perpendicular P, adjacent as a base B, and H as hypotenuse. So you may see these notations too, but I will use opposite, adjacent, and hypotenuse. So now the 6 trigonometric functions that are defined are sine, in short sine of theta, which is defined by opposite over ratio of opposite over adjacent. Next one is cosine, shorthand notation cosine, cos, cos theta, which is I made a mistake here, hypotenuse. This was hypotenuse, and cosine is defined by adjacent over hypotenuse, and tangent is the third one, shorthandly written tan equals opposite over adjacent. There are 3 more ratios or functions which are defined as cosecant, which is shorthandly written as, some places you might see this notation, or some people also like to write cosec. So this is given by reciprocal of sine, so reciprocal of this value, so which is hypotenuse over opposite side. And the next one is secant, shorthand notation sec. This is reciprocal of this one, which is written as hypotenuse over adjacent. And the last one is cotangent, which is reciprocal of the third one, and it's written as cot theta equals the reciprocal adjacent over opposite. So these are the 6 trigonometric ratios. People shorthandly use these things to remember these formulas. Some people use, since opposite is used P, P over H, B over H, and P over B. So H over P, H over B, and B over P. So some people like this notation for in respective of sine, cosine, tangent, cosec, secant, cotangent. So P B P over HHB. So they remember only this, and the remaining other are the reciprocal sign. So first pair, first fraction, second fraction, and third fraction. But some people also like to use 4 sign. They write S. So this is opposite over hypotenuse. So O for opposite, H for hypotenuse. So, and the another relation is C for cosine, C as in cosine, A as in adjacent, and H as in hypotenuse, and tangent, T as in tangent, O as in opposite, A as in SOHCAHTOA. So some people like this, some you may also see this type of, and here are two notations. And uh, in this right angle triangle, the Pythagorean theorem is uh, Pythagorean theorem holds. What is Pythagorean theorem? So if you use uh, C as in third side and A and B for the remaining two sides, so this is always C square plus A square plus B square, or some if you want to use the P, B and H, so this is always H square equal to P square plus so B square. So people use these kind of relations. Now let's solve problem. Say we want to solve problem 1. So solve the following triangle, or say we have a triangle which is, this is 90 degrees, this is theta, this is 5, and this is 12. So solve this triangle. In this case, solve this triangle means finding the 6 trigonometric functions, or let's put instructions here. Find all trigonometric ratios. Trigonometric ratios. So how to solve this? To solve this, we will require all three sides. Do we have all three sides? No. So first we will use Pythagorean theorem. So by Pythagorean theorem, we can find, using Pythagorean theorem, we can find C, which is 5 square plus 12 square equals 25 plus 144, which is 169. And by using finding the square root, since this is a side of a triangle which cannot be negative, so we do not choose negative sign, hence 13. Now we have all, so what are the sides? So we have opposite equals to 5, adjacent equals 12, and hypotenuse equals 13. We plug these values into these formulas, not necessarily this. So these formulas, or that, so opposite is always perpendicular, adjacent is a, and this is h. So using these formulas we can find the ratios. Let's do another problem. Say problem number 2. Problem number 2. If tan theta equals 4/5, find remaining ratios, remaining trigonometric ratios. So how to solve this one? So in this case, since we are given tangent, the ratio, so we know that tangent is 4/5 equals, so what is this? This is always opposite over hypotenuse. So in terms of AB, so this is, you can take it anything but A/B, right, in this fashion. So how do we find again, this is the repetition of previous problem. Actually, in that case you were given two sides. Here also you are given two sides. So now it's just the repetition of the previous problem. You find C first using Pythagorean theorem, and then you have ABC. This will give you C equals, if you plug the values, a square plus b square, you're gonna get 16 plus 25, which is square root 41. So now it's just the repetition of the previous problem. So this is how this problem is solved. Next we're gonna solve another problem. Let's see. Let's say we have this triangle. This is 90 degree, and say this is 30 degree. This is 60 degree. So if this is 30 and this is 60 degree, and say this is 1, length 1, uh, this is 2, and this is square root 3, and we have two triangles, and these are say 45 and 45, and this is 90. So this and these are 1, and this is square root 2. So we can find from these two triangles, we can find the values of all the trigonometric ratios. So by using these formulas, I will take this as an assignment. So write trigonometric ratios theta in here, and ratios over here sine. um, so say 0, we do not have 0 degree, but what do we have here? We have 30 degrees, 45 degree, 60 degree. So this table you can fill up: sine, cosine, and tangent. So by using these two triangles, we can find the values of these ratios. Now there is another way of, so these values are must known values, that we require these values for every time we solve these type of problems. So there are different things, different tricks. So trick 1 to remember these values, trick 1 is, so you start from 0 degree, 30, 45, 60, and 90 degree. So for sine, how do you do is you you find all the, you just write 0, 1, 2, 3, 4, and after writing this you divide, you divide each number by 4 and take the square root. You divide by 4 and take the square root. So these are the respective values of sine. Now what are the cosine values? Cosine values are just the reverse, in the reverse order. And what is tangent? Tangent is just divide sine by cosine. So dividing 0 by 1, it's 0. Dividing this by this, 2 will go away, and you will left with this. So you might also see this type of thing, both are equal. This comes from the rationalization. This is 1. Sorry, I should have put, this is 1, and this is square root 3, and this is infinite. Infinite means not defined. Okay, so 1 over 0 is not defined quantity. This is trick 1. Now there is another trick. Use your left hand. So say this is your left hand, so you have 5 fingers. Say you have 5 fingers. So and you have, say this is your left hand, and now assign these angles to these fingers. So write 0 degree, 30 degree, 45 degree, 60 degree, and 90 degree. To find all the values related with sine, say you want to find sine sine 30 degree. You wanted to find sine 30 degree. How will you find sine 30 degree? You will use this formula, number of fingers square root of number of fingers square root of number of fingers uh, divided by 4 divided by 4 divided by 4, number of square root of number of fingers over. Now how to use this? So say you wanted to find sine 30 degree. So for sine and cosine you have two different rules. Number of fingers, sine always, if you want to find sine, you always use fingers below, number of fingers below that line. So it goes to this line, so this goes to this line, correct? So how many fingers are below? One finger. So 1 square root 1 over 4, which is 1 over 2. What is cosine 30 degree? Cosine 30 degree will be fingers above. How many fingers are above? 3, which is 4, which is uh, square root 3 over 2. Or you can modify this formula for sine and cosine in this fashion. So for sine, number of fingers below square root whole over 2, and for cosine you can write number of fingers above divided by 2. So these are two things you can use to remember these values. Next we do another type of problem. So this problem is related with find exact values. Find the exact values of the following expression. So number A is sine pi by 4 times cotangent pi by 3. Now remember, these values over here that we just discussed corresponds in this way. So this is 0 radian, this is pi by 6 radian, pi by 4 radian, pi by 3 radian, and finally pi by 2 radian. So these are related in this fashion. So here how do we find these values? So sine pi by 4 is sine pi by 4 sine 45 degree, which is square root 2 over 2, and this is cotangent 60 degrees. So cotangent 60 degrees is a reciprocal of tangent 60 degree. What is tangent 60 degree? Tangent 60 degree is square root 3, so its reciprocal is 1 over square root 3, which can be written as this after rationalization. Normally we don't like square roots in denominators, hence the case. So how do we solve it? So multiply over 4, that's the point where you stop. So this is how we solve it. Another problem, cosecant square 60 degree minus sine 45, sine square 45 degrees. Now what is cosecant 60? So it is the square. First of all, what does this mean? This means cosecant 60 degree whole square minus sine 45 degree whole square. So remember, always sine theta times sine theta we write it in this fashion, sine square theta. This is not true. Okay, this is not true, this is true. Anyway, further, what is cosecant 60 degree? It is the reciprocal of sine 60. So what is sine 60? It is square root 3 over 2. So what is its reciprocal? Its reciprocal is 2 over square root 3, but we do not like square root sign, so we write 2 square root 3 over 3. So this is how we write the values. Square minus sine 45 is square root 2 over 2. Right? Now just we simplify things. Did I write it correctly? No, this was square root 3. So this is 2 square is 4 and square root 3 is 3 and this is 9 minus 2 over 4. So this is 3 times 1 and 3 times 3. So 4 over 3 minus 2 over 4. Now make the denominators equal. So you multiply by another denominators of other numbers, which is 4 times 3, 4 times 4 over 3 times 4 minus 2 times 3 over 4. You make the denominators equal basically. So this is 16 over 12 minus 6 over 12. So same thing, 10 over 12. So this is how it is solved. You may put it in the lowest term also. So this is how we solve problems. So now now we will stop here for today, and next time we're gonna continue with some identities, some other formulas. I want to just emphasize on the fact that there are some relations between sine, cosine, tangent and their reciprocals, cosecant, secant and cotangent. So we will review this next time. Thank you for watching the video. Do not forget to subscribe my channel, and if you like the content, please like and subscribe my channel. Also, if you want to ask any questions, please do comment in my videos. Thank you so much. Have a nice day.